Okay, this is 9.2 trigonometry logarithmic functions problem set. So 9.2 problems. And let's start with 47. I think you're going to be fine with the other ones where you're just, well, I suppose we should go back to like the 13 through 30 problems here. Let's go ahead and do number 13. X equals the log with a base 5 of 1 over 625. Now I know I can take a root of 625 just because they give you these problems this way so that they work. So I'm going to write this in exponential form. So I'm going to write it as 5 to the x power equals 1 over 625. Okay, that makes life a little bit easier. And then I'm going to see if there's a root to that, and there is. And of course they're going to work the way I want them to, so that I have 5 in the base. Okay, so I get that. And then I'm going to write this as a negative 4 so that I can get rid of my fraction. And because my bases are the same, my x is equal to negative 4. That's it. That's what you'll be doing. In fact, let's jump down to 27. 13 was kind of an easy one there, but you get down to ones like number 27, they get a little bit trickier. So let's make myself some room here. I'm so anal when it comes to erasing everything. X equals log base 4. Is that a cubed root? Yes, cubed root of 16. Alright, so I'm going to write this as, whoops, gosh, what am I doing? X equals, let's see, let's first convert it to trig form. I was going to do a different way, but let's make it convert it to trig form, or exponential form. 4 to the x power equals the cubed root of, what did I do? I didn't write the 6 on the 16. Duh. Alright, so let's go ahead and write that as 16 to the 1/3. Okay? And then let's try to get these bases the same. So I have 4 to the x equals 4 squared to the 1/3. And then I can use my power rule. And my x then equals 2/3. Okay, so even 27 isn't too bad. Alright, when you get into some that they're asking you to graph, gosh, I don't even know if they're in the homework, but let's look at one like number 49. They give us f of x, and they're saying that equals the log base 3 of x minus 1. Okay, so they're asking us to graph that. What I suggest doing when you graph these is write it in exponential form. So 3 to the f of x, let's just make that a y, equals x minus 1. Okay, so then we go ahead and write this as plus 1 equals x. We've got our x, we've got our y. We just start plugging numbers in, and again you're going to start with your y. I would put a 0 in for y. So that is 1 plus 1 is 2. And then I'll put a 1 in for y, and that'll give me a 4. And maybe I want to put a negative 1 in for y, and that would make this 1/3 plus 1 equals x. So that would be 1 1/3. What did I put in there? I put, a negative 1. And then, you just put those in there and then graph it. And one of the things that you'll notice then is this negative sign, if you remember from 9.1, means that we're going to have a vertical asymptote of x equals 1. So when we graph it, our graph won't be in the general form of log a of x. It'll be with a -1. So that means the graph will not cross that. It'll look something like that. So it shifted over 1 because of this -1. So anyway, when you graph it, it'll automatically shift over, so you don't even have to be aware of that or know that. But anyway, just free information there. Alright, so as you continue on, let's do one in the 60s there, just because those can be a little tricky. So let's do 67. So I'll pause and write that one down, and then we'll do it. Okay, so there's number 67 written out, and what we're doing is we're trying to write this as a single logarithm. So we're going to go backwards and make those exponents. That's all I'm doing here. Everything else I'm going to leave the same. Okay, so it's starting to look a little bit messy. So again, we're being asked to write this in a single logarithm. So let's put those together. So that means we're going to multiply. So we'll just write our logarithm once. And then this is where we get into the brackets and the braces and all that kind of stuff. But really, I'm just going to write it without doing anything else. Okay? And then that's times 25m squared to the 1/2. Come on, where's my 1/2? There we go. To where it looks like that. So all I did, whoops, wrong way. All I did was put them together and made a multiplication with one logarithm, because that's what we're trying to do, is get it into a single logarithm. And so all I did is took out this plus and multiplied those two together. Alright, so now at this point what we're going to do is start combining stuff in here. So let's use the power rule and combine these, and then we'll look and combine these. Alright, so what we've got here, this 5 is to the -2/3, and this m squared is to the -2/3. So let's go ahead and do that. And again, I just kind of make this go on and on because I want to do each little bit at a time. And that's 2 times -2/3. Okay, because of the power rule. Alright, and then I'm going to multiply it, this here. Well, this 25 to the 1/2 is the square root of 25. And this is m to the 2 times 1/2. I'll just go ahead and write it all out like that. Alright, so let's see what we can do with this part here is our next step. And we're just going to leave this alone. And again, we'll come back to it. We'll multiply that and get -4/3. And we'll multiply that by 5m. 2 times 1/2 is just a 1, or we don't even have to show the 1. Okay, so the only thing that I can combine here at this point is this and this. So I'm going to put those two together, the 5 to the -2/3 and the 5m. And that ends up being 5 to the -2/3 times 5 to the m, and then we've got our m to the -4/3. So let's combine these. So log base 5, and we've got our 5 and our 5. This is a 1 here, so we're going to add those. So that would be 5 to the -2/3 plus 1, and then we've got our m and our m to the -4/3 that we haven't done anything with. Alright, so let's go ahead and add those. So I get 5 to the -2/3 plus 1, so that would be a 1/3. Let's do the same thing with our m. We have a 1, and we're adding a -4/3 4/3, so that would give me an m to the negative 1/3. So I've got that, and forget my log base 5. Alright, so now what I'm going to do is write those as a fraction, because that negative 1/3 is kind of in the way. So let's go ahead and write this as log base 5 of 5 to the 1/3 over m to the 1/3. So all I did was made that m to the negative 1/3 positive. Now they both have as their denominators a 3, which means we have a cubed root of 5 over m, which we have log base 5. So that ends up being my answer when I make it down into one logarithm. So a lot of work, a lot of room for mistakes. Make sure you follow the rules, and you should be okay with that. And that's it for the problem set for lesson 9.3.